To start this, what is compound interest? Compound interest is interest calculated on both the principal and on the interest that has already been added. Compound interest computation is based on the principal, which changes from time to time. Interest that is earned is compounded or converted into principal and earns interest thereafter. In other words, your money earns interest, and then that interest also earns interest over time.
Next, I want to show you guys the methodology of the compound interest. The formula of the compound interest is capital S equal to capital P bracket 1 plus I bracket power by N. Capital I equal to capital S minus capital P. Capital P is the original principal, capital S the future value or maturity value, I interest rate per interest period, capital I is the interest amount, I is K per M, K is the nominal interest rate. Important. Annually equal to 1 month, semi-annually per equal to 2 month, quarterly equal to 4 month, monthly is the 12 month.
So for the first question, Zaliha invests 12,300 ringgit in an account that earns 13.5% interest compounded semi-annually. How long will it take for her investment to double in value? So to solve this problem, we have to first list out all the details that we have. For example, the principal is 12,300 ringgit, the interest rate is 13.5%, the M is compounded semi-annually, so 6 months, so 2 times in a year. And lastly, we know that the sum at the end of this investment will be double in value, so we can times the principal twice, which equals up to 24,600 ringgit. And to solve this problem, we will use the formula S equals to P bracket 1 plus I bracket to the power of N. Now we can substitute all the values. So S is 24,600 ringgit equals to P, which is 12,300 ringgit, bracket 1 plus our I, which is 0.135 over 2, bracket to the power of 2T. So to simplify this equation, we will divide 24,600 ringgit with 12,300 ringgit, which equals to 2, equals to 1.0675 simplified to the power of 2T. And to bring down the 2T, we have to add log, which equals to log 2 equals to 2T log bracket 1.0675 bracket. To further simplify this equation, we will divide the logs, and 2t will equal to log 2 over log bracket 1.0675 bracket. And when we calculate that, we will get 10.6116. And to get just the t, we will divide that with 2, and we will get t equals to 5.31 years.
Question B. Mazila invests RM20,000 in the account that earns 7.5% interest compounded quarterly. Question 1. Find the amount Mazila will reserve at the end of the 5 years. Question 2. After 5 years, the bank increases the interest rate to 8% compounded quarterly. Find the amount in Mazila account at the end of the 7 years of investment. For the question 1, we get the information is receivable value is 20,000, interest rate is 7.5%, M is a 4 month, year T equal to 5 years, N equal to 20, S is a maturity value, so we don't know. We use the compounded interest formula. S equals, so the first maturity value we get is 28,998 per 99 cent. Question 2, we use the formula S for the receivable value at this version to 28,998.99, R equal to 8%, M is a 4, T we get 22 years, maturity value we don't know, so we use the same formula. We get the answer is the S equal to 13,379.90 cent.
So question 2, A. 5 years ago, Ahmad deposited 15,000 ringgit into an account that earns 5% interest compounded monthly. Today, he plans to add RMY to the account. Find the value of Y if he wants to have 45,000 ringgit in the account 10 years from today. So there are 2 calculations that we will be doing, which is from 5 years ago and 10 years after from today. And again, to start, we will list down all the details that we have. The principal is 15,000 ringgit. The I is equals to 0.05 over 12. The M is 12 because it compounded monthly. The T is 5 years. And then the details for the 10 years after from today, we will change D to 10 years, and everything else is the same. We will use the formula S equals to P bracket 1 plus I bracket to the power of N. We will get the value of S, which is 19,250.38 cents. And then for the 10 years after from today, we will use the same formula, and we will substitute all the values as usual, which is we will get P value, which is 27,322.25 cents. And we want to find the value for how much he added to the account today. So we will get that value by subtracting the 10 years after with the 5 years ago, which is 27,322.25 cents minus with 19,250.38 cents, and we will get Y, which is equals to RM 8,071.87 cents.
Question 2, Part B. Zaliha invests RM7,000 at the interest rate of 6.4% compounded monthly for the first 6 years and 6.0% compounded every 4 months for the next 4 years. Find the maturity value and the total interest earned by Zaliha at the end of the investment. First 6 years, P equal to 7,000, R equal to 6.4%, M is 12 month, T is 6 years, N equal to 72. Next 4 years, R equal to 6%, M is a 3 month, T equal to 4 years, N equal to 12. We use the compounded interest rate formula to searching the majority value. S equal to P bracket 1 plus I bracket power by N. Majority value is S equal to 10,296.54%. So the next 4 years we use the past majority value as principal original at this formula. So at the majority value we get is S equal to 1320.49 ringgit. So the total interest we get is S6020.49 ringgit.
An annuity is a series of periodic payment or deposit, usually made in equal amount at regular periods. A large sum is paid upfront, and it is then repaid back in a smaller amount over time. There are two main types of annuities. In an ordinary annuity, payments are made at the end of each period, while in an annuity deal, payments are made at the beginning of each period. The timing of payment affects how much the annuity grows over time.
So I'm going to explain the annuity formula, which is a formula used when we make equal payment over a fixed period of time. What is an annuity? Annuity simply means a series of equal payments made at equal time interval. For example, paying your loan every month or depositing money monthly into a saving plan. Annuity formula for monthly installment. When we take a loan, we receive money now and pay back in equal installments. They use the present value of an annuity formula, which look like this. Here what each determines: P equal to present value of the loan amount, I equal to interest rate per period, N equal to total number of payments, R equal to regular payments, usually the monthly installment. This formula tells us how much you need to pay every month so that the loan is fully settled after n months. Annuity formula for saving, future value. There is also a second annuity formula used for saving or investment. This tells us how much money you will have in the future if you deposit the same amount every period. The formula look like this. A equal to future value, R equal to regular deposit, I equal to interest rate per period, and N equal to number of deposits. This formula shows how monthly deposits grows over the time with compound interest. Now I will explain how we find the monthly payment for this loan question. Penang Bank offers a personal loan of RM250,000 with an interest rate of 4.8% compounded monthly. The customer needs to pay back the loan through monthly payment for 25 years. To solve this, we use the annuity formula. First, we convert the yearly interest rate to monthly. Next, we calculate the number of payment over 25 years. N equal to 25 times 12 equal to 300. Now we substitute everything into the formula. So the monthly payment that the customer must pay is RM1432.49. Now let's move on to part B. The question says that after paying the 288 monthly payment, the customer wants to settle the remaining balance of the loan immediately. So we need to calculate how much is still owed after the 288 payments. We will use the present value of the remaining payments formula. Here, capital letter R equal to RM1432.49. The monthly payment we found in part A. Small letter R equal to 0.048 per year, N equal to 12, and monthly interest rate equal to 0.004. Next, we find how many payments are left after the 288 payments. So total payments are 300 and payment mates are 288. So the remaining payments are 300 minus 288 equal to 12. Now we substitute the values into the formula. When we calculate the expression inside the bracket, we get the amount of the remaining loan balance. So A equal to RM16751.16. So the amount the customer needs to pay to fully settle the loan after the 288 payment is RM16751.16.
Type B, question 2. Alicia borrowed 25,000 ringgit Malaysia to buy a sofa set. She agreed to settle the loan for monthly payments at 4.8% compounded monthly. A. Find the monthly payment and total interest charge. B. If she failed to pay this 5-month payment, find amount that she must pay on the 6th payment to settle the outstanding areas. For the first, we have to find the monthly payment. In question 1, we have to find the interest charge. To find the monthly payment, we will have to use present value formula to find R. As a result, R equal to 1,094 ringgit 55 cents. Next, for the interest charge, we will be using formula bracket R times N bracket minus A, which is 1,094 ringgit 55 cents times 24 and minus 25,000 equal to 1,269 ringgit 20. Next, moving to the second question. The question, the end is 6 because Alicia had outstanding from the first 5 months and she want to pay on the month 6. We want an outstanding value to settle the outstanding areas. Firstly, we have to identify what the formula we use. So, the correct formula to use is a future value formula, which is after the calculation 6,633 ringgit and 32 cents.